Hello guys, guess what? We're going to be learning Boyle's law together, and I'm going to be taking you around every singular thing as far as Boyle's law is concerned from beginning to the end regarding your Jamb and your Waec. Listen carefully, this is not your normal or your regular Boyle's law that you already know. A lot of people will say, I know Boyle's law already, I know Boyle's law. Please don't do that. As we learn together, you are going to see a lot of things that you have never seen before in Boyle's law, and you're going to be seeing their past questions. Are you ready with me? Yeah, let's go. This is our lesson 2, right? Oh yes, lesson 2. We have looked at 5 lessons already on that kinetic theory of your matter. I've treated that, and then we're looking at your gas laws. So this is lesson 2, Boyle's law. So in Boyle's law, what should I know? The first thing is the definition of Boyle's law. Go straight to the point. First and foremost, Boyle's law was introduced by who? Robert Boyle. Robert Boyle, an Irish chemist. So the guy is from Ireland. Are you getting it now? So what did the guy postulate regarding Boyle's law? He went further to tell us that Boyle's law states that the volume, right, underline the word volume, of a given mass of gas is what? Inversely proportional to the pressure. In other words, volume is an inverse proportionality of what? Pressure. That was what Boyle was driving our attention to. He said that the volume of a given mass of gas is what? Inversely proportional to the pressure, provided that what? Temperature remains what? Constant. In as you are keeping temperature constant, volume is an inverse proportionality of your what? Your pressure. I know the question some of you now ask, sir, what about pressure? If pressure is coming first, of course, it's still the same thing. Like us saying that, okay, well, pressure is inversely proportional to your what? Your volume. Whether volume is inversely proportional to pressure or pressure is inversely proportional to volume, provided that what? Temperature is kept constant. We don't have issue with that. Does it make sense? Again, what does that mean? Listen carefully. If your volume is inversely proportional to pressure, or your pressure is inversely proportional to your what? Your volume, what it means is this. If pressure is increasing, so as pressure increases, what will happen to volume? Volume will begin to decrease. So according to Boyle's law, when pressure increases, what happens to volume? Volume will what? Decrease. Or when pressure now, when you are decreasing pressure, what will happen to volume? Volume will begin to what? Increase, provided that temperature is kept what? Constant. If you understand this thing that I've just said now, answer these 2 questions fast. Jamb 1979 question 35. Jamb brought this interesting question, and the question says, which of the following statement is true? Now let's go. Option A there says, an increase in temperature of a given mass of gas increases the number of molecules of the gas. Now listen, this guy has nothing at all to do with your what? Your Boyle's law. But please, let's analyze the statement first. An increase in the temperature. If I increase temperature of a gas, right, of a given mass of gas, will it increase the number of gas molecules? No, it's not actually going to increase the number of gas molecules. Rather, what it's going to increase is that it's going to increase the kinetic energy, right? It's going to increase the velocity of the gas molecule. That's what it's going to increase there. Are you getting it now? So option A cannot be the answer. Option B says, an increase in the temperature of gas does not affect kinetic energy. You have lied. Why? Because an increase in temperature will automatically affect your what? Your kinetic energy. That's why we said that your the temperature, right, is a direct proportionality of your what? Your kinetic energy, because as temperature increases, kinetic energy is going to what? Increase. I've explained all of those things in the previous classes. Now look at option C. Option C say an increase in the pressure of a gas. So as pressure is increasing, what will happen? They say pressure is what? Proportional. An increase in the pressure of gas is proportional to the volume, to increase in what? Volume. That's not true. No. Boyle's law states that as pressure is increasing, what will happen to volume? Volume should decrease, not increasing with it. And then look at option D. A decrease in the pressure. First, only you reason it, don't read the entire statement. If you decrease pressure, what should happen to volume? Volume should what? Increase. Option D says a decrease in the pressure of the gas is proportional to an increase in the volume at constant temperature. That's Boyle's law for you. What is the answer? Option what? D is the correct answer. I know somebody will say, sir, but they say proportional. They did not use directly proportional. Come again. I said that pressure is what? Inversely proportional to your what? Your volume. Right? That was what Charles was saying. If pressure is inversely proportional to volume, it means that as pressure increases, right, what will happen to volume? Volume will what? Decrease. Or as pressure decreases, volume is going to increase. That's what option D is saying. Option D says a decrease in the pressure of the gas is proportional to an increase in the what? Volume at constant what? Temperature. That's the answer. Are you seeing it now? Look at the next question, question 2. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. Jamb 2012 question 5. A beautiful question was asked, and the question says, an increase in the pressure exerted on a gas at constant temperature will result in, only you picture it out yourself, an increase in the pressure. So if you are increasing pressure, what will happen to volume? First, that means as I increase pressure, volume is going to do what? Decrease, provided your temperature is kept what? Constant. Option A says a decrease in the number of effective collision. We don't have business with our collision there. That's not what we are going into first. But please understand, can A even be the answer? An increase in pressure. If you increase pressure, what will happen is that there will be an increase in the number of collision. Why? Because the molecules of the gas, as you increase pressure, they collide with themselves more. So A cannot be the answer. Option B says a decrease in volume. If you increase pressure, according to Boyle's law, volume is going to do what? Decrease. Making sense. Look at option C. Option C says an increase in the average intermolecular distance. As you increase pressure, an increase in pressure will decrease the intermolecular distance of the gas. When pressure increases, intermolecular distance will decrease. Because intermolecular distance decreases, what will happen? The density of the gas will do what? Increase. Simple. I've explained those things in the previous classes, so just be following me. Option D is an increase in volume. No, if you increase pressure, volume will rather decrease than for it to come and increase. What is the correct answer? Option B is the answer. Simple thing. So you see that all these things are interrelated in Boyle's law. Very simple. If you get that very fast with me, I'd like you not to forget this very quickly. What is the relationship between pressure and volume as stated by Robert Boyle's? Let's go. Boyle's gave us clearly that what? Your volume is inversely proportional to pressure, or your pressure is inversely proportional to your what? Your volume. Don't play with it. Volume is inversely proportional to pressure, or pressure is inversely proportional to what? Volume. Look at the questions now. Waec 2014 question 21. They brought this powerful question all the way. And the question is, which of the following relationships correctly expresses Boyle's law? Which one expresses Boyle's law to us? Option A says your pressure is proportional to volume at constant temperature. No, it's not true. Pressure is inversely proportional to volume. Option B says volume is directly proportional to your what? Your temperature. Is volume directly proportional to temperature? No, this is not what? Boyle's law at all. Look at option C. Option C says pressure is inversely proportional to volume at constant temperature. Exactly. That's your Boyle's law. Either pressure is inversely proportional to volume, or you say what? Volume is what? Inversely proportional to your what? Your pressure. That's your Boyle's law for you. And look at option D. Option D says volume is inversely proportional to temperature. That is not true. That's not true. What is kept constant there is temperature, right? And then pressure is inversely proportional to what? Volume, not directly. So what is the answer? Option what? C becomes the correct answer. Very easy and direct. Look at another powerful question. Waec 1998 question 8. What did Waec bring? Waec got this powerful question that says Boyle's law can be expressed mathematically as. How do you express it? Option A, we're given that your volume is inversely. You are doing well, bro. You said that that's correct. That's true. You are very correct. Why? Temperature is kept constant. Volume is inversely proportional to pressure. Option B says V1 all over T1 is equal to V2 all over T2. This guy can never be the answer because first there, in your Boyle's law, temperature is kept constant. So in this option B, temperature has relationship. That cannot be the answer. You have entered another thing, and that's your Charles law there. Option C says your volume is directly proportional to temperature and pressure is kept constant. No, in your Boyle's law, temperature is kept what? Constant. And then option D says pressure is directly proportional to temperature. That cannot be the answer. What is the answer? Option A is our correct answer. Simple, easy, direct. Are you catching these things? If you dey catch and drop am for me, say Sapia, they feel you. Man, they see am. Yeah, let's go. I like you not to forget this very quickly with me. What is the mathematical expression of Boyle's law? It states clearly that your what? Volume is inversely proportional to pressure. Right? Simple. Now, if volume is inversely proportional to pressure, what does it mean? Oh yeah, follow me. Let's do some small solvings here. It means that volume here is equal to K all over your P. If volume is equal to K all over P, that means can I cross multiply? Yes. Make this all over 1, then cross multiply. It means that your PV, what will it equal to? Is equal to your K. And this K there is your what? Your constant, right? Yes. Now, what happens when I have two different gases that I want to relate them with Boyle's law? What is going to happen? It means if I have two gases, right? You know, if PV is equals to K, it's very true to say, okay, if the gases are 2, that means P1, V1 is equals to K, right? So this guy is our what? Equation 1. Or P2, V2 is equals to what? K. This is our what? Equation 2. Can I equate equation 1 and equation 2? Yes. If you watch, K and K are the same. Because K and K are the same, it means that my P1, V1 is equals to your P2 and your what? Your V2. This is the formula we're going to be using to solve everything about Boyle's law. So what is the mathematical representation of your Boyle's law? Your P1, V1 is equals to P2, V2, provided what? Temperature is kept constant. Your P1, V1 is equals to your what? Your P2, V2. Will you forget it? Never. Well, let's go together. Look at this question. Jamb 2010 question 5. The powerful question all the way says the volume of a given mass of gas is VCm cube. That's the volume, VCm cube. At pressure P in what? Millimeter mercury. They say what is the new volume? What is the new volume of the gas if the pressure is reduced to half? You don't even need to solve. Just saying this alone, I know the answer. Direct. Listen, volume is given as VCm cube. Pressure P millimeter mercury. What is the new volume if the pressure is reduced by half? According to Boyle's law, follow me, come. What did Boyle's law state? Your pressure is inversely proportional to your what? Your volume. It means as pressure is increasing, volume is what? Decreasing. Or as volume is increasing, pressure is decreasing, vice versa. Come. The question says, what is the new volume, right, if the pressure is reduced by half? If you reduce pressure by half, volume will multiply by 2. Simple thing. We have only logically used explanation to get this answer. If you reduce pressure by half, if pressure decreases by half, volume will increase by that same factor that pressure is decreasing by. So if, for example, pressure is decreasing by 3, volume will multiply by 3. If pressure decrease by 2, volume will multiply by 2. Option A says, very good. Let's go. Option A says V will decrease by 2. No, that's not true. You reduce it by 2. No, that's not true. Option B says V is equal to B is what? VCm cube. That's not it. Volume should multiply by 2. Option C says it will multiply by 4. This says it will multiply by how many? 2. What is the answer? Option D is the answer. You don't really need to solve. D is the answer. I know somebody is confused. Sir, can you just solve so that I will see it? Come, let's go together. From Boyle's law, we said that your what? Your P1, V1 is equal to your P2, V2. Now, pay attention closely. From here, what can we deduce here? Your P1, let's go with P1 first. What's your P1? P1 is your what? Your P millimeter mercury. P what? Millimeter what? Mercury. What's your V1? V1 is VCm cube, right? Oh, yes. And the question says, what is the new volume? In other words, new volume is V2. We don't know V2. If the pressure is reduced by half, that means our P2, right? P2 is what? Reduced by half. if my pressure P2 is now reduced by half, what will it give me? It will give me P all over 2 in what? Millimeter what? Mercury. That's what I'm going to have there. Now, from this relation that we have, your P1 V1 is equal to P2 V2. What am I going to have? Now, apply your Boyle's law there. What's your P1? P1 is P millimeter mercury. That's your P, right? Times, what's your V1? V1 is V. Forget their unit first. V is equal to, what's your P2? P2 is P over 2. That's P all over 2 times my V2. V2, what's your V2? I don't know the value of V2. That's your V2 there. That's what we're solving. So now, what is this going to give me? It means that my P times your V is equal to, multiply this guy here for me. If you multiply this guy, what are you going to have? Your PV2, right? Oh yes, divide by 2. So cross multiply. That means your 2PV is equals to your PV2. Can P come and cancel this P here? Yes. If P cancel P, what's your V2? Your V2 is going to give you what? 2V. And that is what we have gotten. 2V Cm cube. Wherever you are out of there, easy and direct. Simple. Don't forget, in your Boyle's law, according to Boyle's law, if pressure is reduced by half, volume will multiply by how many? 2. That's it. If you get that very fast with me. So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this. As a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you are putting your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or Waec. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, click Waec Jamb Pursuit TME, right? As the select education. Select level. You are not preparing for Pursuit TME, you are preparing for Jamb and Waec, right? Okay, click on the what? Jamb and what? Waec. And then create your account. 2 seconds. Pass. You don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do you do? Start learning. I'd like you not to forget this. Answer this question. 1982 question 3. Can we go together? The question says, the pressure on 100 cm cube of oxygen at 35 cm cube is 750 millimeter mercury. Now let's go gradually and solve it and see. Now the question says, what will be the volume of the gas if the pressure is increased by 1000? Is increased to 1000 millimeter mercury without changing the temperature. So without changing temperature, I've already informed you that temperature is kept constant. And which one is temperature kept constant? Boyle's law. So if temperature is kept constant here in Boyle's law, what is the formula for Boyle's law? From Boyle's law, your P1 V1 is equal to your what? Your P2 V2, according to Boyle's law. The question says, the pressure on what? 100 cm cube of oxygen. What's your V1 there? That's your V1 is what? 100 cm cube, right? The pressure on 100 cm cube of oxygen at 35 degrees Celsius is what? 750 millimeter mercury. So what's the pressure there? P1. Pressure is always in millimeter mercury now here, or atm. So what's your P1? 750 in what? Millimeter mercury. That's our P1. The question says, what would be the volume? Right? What would be the volume of the gas? That means your V2, which is the volume of the gas. We don't know it. What will be the volume of the gas if the pressure is increased to what? 1000. So pressure now, your new pressure, that's your P2. If it is now 1000 cm cube, get for us your V2. That's what the question is saying. So from your P1 V1 is equal to P2 V2. Oh yeah, put everything in. What's your P1? Your P1, what is the value? 750. 750, right? Multiplied by, what is your V1? Your V1 is what? 100. 100 is equal to, what's your P2? Your P2 is what? 1000. 1000 multiplied by your V2. That's what we are looking for, V2. We don't know it. From this now, it's very simple. Can I divide all through by 1000? Divide here by 1000. Come and divide this guy here by what? 1000. 1000 come and cancel 1000. I can get V2 easily. 10 we cancel 0. 0 we cancel 0. This 0 come and cancel this 0 here. What am I going to have? I'm going to have 75 times 1. That's 75. Divide by 1 is 75. Is equal to my what? Your V2. So what's our V2? V2 is equal to what? 75. Volume. What's the unit of volume there? Cm cube. 75 cm cube is the answer. So let's keep it one side. 75 what? Cm cube. And then let's check the options and see what is the answer. Are we good to go? Yeah, let's go. Yeah, let's go. So which one is the answer there? Option A all the way says 133.3. That cannot be the answer. Option B, is that the answer? No. Is it option C? Yes. Option C is 75 cm cube. Option D says 65. So what's the correct answer there? Option what? C, 75 cm cube is the answer. Only by applying your what? Boyle's law, you have gotten it out of there. Does it make sense? Look at this question very quickly. There are a lot of questions under the calculations, a lot of them from both Jamb and Waec. A lot of them, they are all in the notes. So immediately you are done with this class, go to the notes and go and answer all the questions. Skip no one. 1991 question 5. Look at the question. 30 cm cube of oxygen at 10 atmosphere pressure. That's 8 cm. Now, first, without even stressing yourself, 30 cm cube of what? Oxygen. That means your V1. What's your V1? 30 cm cube. At 10 atmosphere pressure, that's your P1. P1 is what? 10 atm. That's atmosphere, right? Is placed in 20 cm cube container. That is your V2. Is what? 20 cm cube container. Calculate the new pressure if temperature is kept constant. Because temperature is constant, that's your what? Your Boyle's law. Calculate the new pressure. P2 is equals to what? Unknown. From your Boyle's law, want to go, what's your Boyle's law? P1 V1 is equal to your what? Your P2 V2. What are you looking for? You're looking for P2. You can decide to say, okay, sir, let's make P2 subject of the formula. You still get your answer. Make P2 subject of the formula. P2 will give you what? P1 V1 all over your V2. Oh yeah, let's solve it and go. Guys, let's go. What's your P2? P2 is equals to, very fast, what's your P1? P1 is 10 multiplied by your V1. What's the value of V1 from the question? 30 divided by your V2. What's your V2? 20. So if this guy come and cancel this guy, 2 here, 1, 2 into 10, how many? 5. 5 times 3. So your P2 is equals to your 5 times 3. And that will give you 15. 15, what's the unit of pressure there? ATM. 15 ATM is the answer. So let's check it out and see the one that is 15 ATM. So what's our answer? 15 ATM, right? Oh yeah, let's check it out and see. Option A says 6.7. No. Option B says 15.0 ATM. Yes, that's 15. Option C says 6 ATM. B says 66 ATM. What is the answer? Option B is the answer. Does it make sense? Don't skip anyone. Immediately you finish this class, go straight to the notes. There are calculations questions in abundance. Go and finish all of them. Both Jamb and Waec question, all of them have been answered there for you. Go and solve them yourself and ensure you get all of them. Yeah, let's continue. The important thing you must know now is the graphical representation of Boyle's law. Oh yes. How do we represent Boyle's law graphically? That's the question. So in the graphical representation of your Boyle's law, there are 3 cases. How many cases? 3 cases. How many special cases do we have? 3 of them. And we must look at all of them one by one and get them. Now, what is the first case? The first case, right, that involve the graphical, any of the 3 graphs, they are very correct, but understand the salient points around them. Look at the first graph. This is how it is presented. And this is a graph of pressure. You know, pressure now is in Newton per meter square, right? Yeah. So this is a graph of pressure against volume, and that volume is a cm cube. A graph of pressure against volume. Now, if you see a graph like this, and then it's coming down, this guy is like this is like this here. What does it tell us? It's telling us that that graph is inversely proportional. First thing to hold tight. If I see a graph like this and the graph is like this, what is this graph telling me? This is A. A is inversely proportional. You don't need anybody to come and explain it for you again. Your B here is direct proportionality. But there are things we check out for to know whether we are in line or we are not in line. This guy A, we said that is direct, is inversely proportional. That means your pressure and your volume, according to your Boyle's law, what happened to them? Your pressure is what? Inversely proportional to your what? Volume. That's your Boyle's law for you. Why? Because if I see a graph like this anywhere in my dream, and then I see something of this nature, what does it mean, everybody? Inversely what? Proportional. Two things to hold tight. Follow me. The first thing to hold tight here, number one, is a plot of pressure P against volume, right? Is this particular curve that is going down like this now that you can see. And if you watch the we are made to understand that that curve or that graph is what? Asymptomatic. What does the word asymptomatic mean? It is asymptomatic with both the x and the y axis. What it means is that it is not touching this is your y axis now, and then this is your x axis. This curve here is not touching the y axis, it is not touching the x axis. It's just curving down like that. What is it? Asymptomatic, number one. Number two thing to hold tight is that this graph shows that pressure and volume, what is happening to them? They are inversely what? Proportional. If you catch that, I don't have business with you. You understand it already. That means you can now flow into the next. Then case 2 is when it presents like this. And from this, what can we see? This is a graph of pressure, right, against 1 all over volume. Come. According to your Boyle's law, pressure is inversely proportional to volume, right? And then I told you that if you see a graph like this, what does it mean? It means it is what? Inversely proportional. But when you see a graph like this, what does this guy mean? Directly proportional. But now, look up. This guy, here is pressure, P. Here is 1 all over V, not V. I wish it is P here, and then here is V. Man, this is never Boyle's law. Now, what makes it to be Boyle's law is because here is what? 1 all over V. If here is 1 over V, automatically, that makes it what? Boyle's law. Because your pressure and volume, now, we said that pressure is directly proportional. This straight line graph here is saying that it's what? Directly proportional. That means pressure is directly proportional to what? 1 all over what? Volume. Yes. And this is what Boyle's law is telling us. Does it make sense? If you watch this denominator on the x-axis that we have there, it is 1 over volume, not just volume direct. And 2 things too, you should hold tight there. So what are the 2 things there? Number 1 of them is that a plot of pressure against 1 all over V. Against 1 all over V. Or a plot of V against 1 all over P. What will it give? It will always give a straight line that will pass through the origin. Does it make sense? And the second thing to look at is that the graph shows that pressure and volume, which of the volume? 1 all over volume, they are directly proportional. So pressure is directly proportional to what? 1 all over volume. And this is the graphical representation of your what? Your Boyle's law. Does it make sense? And the third thing to know, which is the case 3, is a graph like this. Now follow me. This is your PV. That's your pressure times volume against either pressure alone or volume alone. And what is it going to give? It's going to give us a graph that is like this, like this. What it means, are you getting it now? This is the x-axis, and then here is your what? Your y-axis. What it means is that your PV there is uniform. PV, the product of pressure and volume, they are what? Uniform or true. Are you getting it now? And you don't really need anybody to come and tell you what will be the gradient of this type of graph to give you 0 at the end of the day, right? So what should I know here very fast? Follow me, let me show you. What you should hold tight here very quickly is that a plot of PV, pressure times volume, against pressure alone or volume alone is a straight horizontal line graph, period. So how many graphs have I given you? 3 altogether. Case 1, case 2, case 3. Now, answer this question for me very fast. WAEC 2022 question 41. You can see 2022 exam question 41. WAEC brought this powerful question. The question says, which of the following sketches is a graphical representation of your Boyle's law? Which one is a graphical representation of your Boyle's law? Option A, we're giving something of this nature. Now, pay attention. Here is your P and here is your V. Is this guy, you can see that it's a straight line graph, and it's telling you that it is what? Directly proportional. The question is that, is pressure directly proportional to volume in your Boyle's law? No. So option A can never be the answer. Simple thing. Look at option B. Option B there gives us your volume and temperature. Is there a relationship between volume and temperature in your Boyle's law? No, that is not true. So that cannot even be the answer, for crying out loud. So it can't be it. Are you getting it now? Look at option C. Option C says your pressure is, now this type of graph like this, if you see something of this, what does it mean? Directly proportional, right? That means your pressure is directly proportional to 1 all over volume. Is that Boyle's law? Yes, this is Boyle's law. So C is making sense. Look at option D. Option D has given us straight line here. Now, and here is just P. This guy is P, and then here is 1 over T. No, that cannot be it. What we need there, this on the y-axis there, we expect PV there. And then on this x-axis, what do we expect there? Either P or what? V. So this guy cannot be the answer. What is the correct answer? Option was C is the answer. Easy and direct. You are out of there. Does it make sense? If you understand this and you are very, very, very sure that you understand this very carefully well, that means you can fire down. Please don't forget any of those 3 cases I gave you. Pay attention to those 3 cases regarding the graphs that represent your Boyle's law. If you get that very fast, the next thing you must know is the explanation of Boyle's law using what? Kinetic theory. So how do we validate your Boyle's law using your kinetic theory? It's very simple. 2 things to note here. Now that you have created your account, right, for you to start learning, what do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they are all there for you, right? What do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your JAMB syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display history of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Hello, friends. Your class will start playing for you. It's easy and it will start playing for you, easy and direct. And what happened? You can even choose to make it full screen. Right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use Nightsub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it starts loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number one answer is B. Why is the answer B? It is explained for you in details. Every singular thing. And then you are following your classes. You are done with that. You come to the next. You see your notes. Everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out. You too much. Everything is structured and organized for you in the app, right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the what? Order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your WAEC cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosomal. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
Now look at the two things. Let's call here A and let's call here B. How can I use these two experiments to validate your Boyle's law using your kinetic theory to view it in general? Number one is if the volume of a fixed mass of gas is increased at a constant temperature. Now, listen to this. The mass of A and the mass of B, both of them are the same fixed mass. If the volume of a fixed mass, right, is increased at a constant temperature, A and B, tell me which one have higher volume. You can see that the volume from here like this down to this point, right, this guy here is more. So A has higher volume. So if the volume of a fixed mass of gas is increased at a constant temperature, what happens? It's different from in the B, right? Oh yes, this guy here is your B. Now what has happened there? The volume of a fixed mass of gas is reduced at a constant temperature. How can we use Boyle's law to explain the two of them? Right? We are following me from here. Let's look at it. Let's start with the first. If the volume of a fixed mass of gas is increased at a constant temperature, picture that A in your mind. Volume is higher. The mass of A and B, they are the same, right? But this guy here say that if the volume of a fixed mass of gas is what increased at a constant temperature, the first thing that happened there is that the gas molecules, they now have the opportunity to do what? Spread out. Why? Volume has increased. And because the gas molecule spreads out, what will happen? The average velocity of the gas molecules, they are going to decrease. There is no pressure that is built up in them. And because no pressure is built up in them, average velocity of the gas molecule will decrease because the volume has increased. Their velocity is going to decrease because they have greater distance. Each of those particles in the gas, they have greater distance to cover. And what happens from there? The third thing is that the container becomes larger. You know, because you have increased volume now, container is larger. The volume of the container is larger. And then another thing is this, the number of collisions per molecules, the number of collisions of those gas molecules now, per unit area decreases. Oh, now look at it. volume has increased, right? Because volume has increased, where we go and see another particle of gas is kind of like far. So we are not going to be colliding that frequent. Why? Because the number of collision is going to decrease. Why is number of collision going to decrease? Simple. Because there is increase in the volume of the container. So their collision is going to decrease. And as a result of that, what happens is that the pressure decreases. Now listen. If you increase your volume, right, in a fixed mass of a gas, what will automatically happen to pressure? Pressure is going to decrease at the end of the day. It's different. Now, look at it now. Look at it. From this guy that we have here, you have increased the what? The volume of a fixed mass of gas. Temperature is kept constant. Every other factor is kept constant. What will happen there? The collision between each particle and the next, what will happen to the collision? Is going to what? Decrease. Is the pressure they're going to increase or pressure is going to decrease? Pressure there is going to decrease because they have larger distance to cover. So there is no frequent bombardment of the molecules of the gas with the walls of the container. Pressure will do what? Decrease. So an increase, right, in the volume of a fixed mass of gas. That's how Boyle's law. Now what does it state? Boyle's law states that an increase, right, in the volume of a fixed mass of gas, what will happen? It is inversely proportional to pressure. Pressure will automatically decrease. Are you getting it now? Look at the case 2. If the volume of a fixed mass of gas is reduced at a constant temperature, what happens there? The first thing is that the gas molecules becomes closely packed. As you compress it, right, volume has decreased. The gas molecules become closely packed. And because they are closely packed, you should know that density will increase because they are now closely what? Packed. Yeah, let's go. The next thing there is that the average velocity of the gas molecules will increase. They are closely packed. Everybody's now colliding with each other. Any small thing, they are colliding with each other. So the velocity of the gas molecule will increase. As the velocity increases, what happened there? The time taken for molecules to collide with the walls of the container is now shorter. Because it is shorter, what happened to pressure? Pressure will increase. So the number of collision per unit area. Number of collision per unit area. What is pressure? Pressure is equal to force all over area. The number of collision, the bombardments on the walls of the container per unit area, what is going to happen to it is going to increase. Right? Yeah. As it increases there, what happened? Pressure increases. So whenever you decrease volume, pressure increases. Whenever you increase volume, pressure will do what? Decreases. Does this explain your kinetic theory for you? Yes. If you want to understand this very quickly with me, bro, again, don't forget this is the diagram. As you decrease the volume of a fixed mass of gas, what will happen to pressure? Pressure will increase. But if you mistakenly increase volume of a fixed mass of gas, pressure will do what? Decrease. Does it make sense? If you get that very fast, answer this question for me. Jamb 1983 question 35. Jamb brought this interesting question, and the question, what do we say? Increasing the pressure of a gas. If you increase pressure, what will happen to volume? Volume will decrease. Well, let's go. Or should they say to lower the average kinetic energy of the molecule? It's not true. If you increase pressure, the average kinetic energy of the molecules will do what? Increase, because you have increased pressure. The bombardment, right, is going to increase. Kinetic energy will increase. Option B says it will decrease the density of the gas. Now listen, if you increase pressure of a gas, what happens to density? Density does not decrease. Now, when you increase pressure, it means that the intermolecular distance between the gas has been what? Reduced, and density will increase. So density will never reduce. That's not still true. Option C says it will decrease the temperature of the gas. When you increase pressure of a gas, if you increase pressure, pressure does not have anything to go and do with the temperature there. First, pressure doesn't have anything to do with temperature. Why do I know that pressure has no business with temperature there? According to Boyle's law, right? Your pressure is inversely proportional to your volume at constant temperature. So temperature is kept constant there. So pressure has no business, temperature has no business there. Now look at option D. Option D says increasing the pressure. The question says increasing the pressure of the gas will increase the density of the gas. Yes, when you increase pressure, force per unit area increases. automatically density will do what? Increase. That was the correct answer. Option what? D is the answer. Simple, easy and direct. Where you are out of there. Does it make sense? Do you understand this? I beg you, play this class again, and grab every single Latin I just explained. If you understand it, you see that this, your Boyle's law is different from normal Boyle's law that you already know, right? Yeah. Again, what is kept constant in Boyle's law? Temperature is kept constant. Can I say something? Because temperature is kept constant in Boyle's law, can we say that your Boyle's law is isothermal? Isothermal, yes. Your Boyle's law is isothermal. Iso means equal. Thermal, temperature. Temperature is kept constant in Boyle's law. So Boyle's law is isothermal. Are you getting it now? If you understand that very quickly with me, please, I'll see you in the next class shortly. But before I see you in that next class, first thing, go to my notes. Go and finish all the questions in the notes. Next thing, practice CBT. Keep practicing CBT. And the third most important thing, invite a friend. Tell a friend about the Learn Lift app. Are you getting it now? Tell a friend to watch the classes with you. And I'll see you in the next class. We're going to be looking at what? Chart's law. A lot of things to look at in Chart's law. For the now, peace out. Bye-bye. 350 is the target. And you must do well in this jam. Bye-bye. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the Learn Lift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.